Hello, my name is Sergio and I'm going to tell you a bit about my Summer of HPC project here at the IT for Innovation's National Supercomputing Center in Ostrava, in the Czech Republic. The boundary element method, BEM, is a numerical computational method for solving partial differential equations. The BEM4i software can be used to apply this method on the simulation of the Wi-Fi signal propagation inside buildings. My job has been the development of tools that integrate with BEM4i to make its usage and visualization of the results easier. The two tools I've developed are called FlatMeasure and Wi-Fi Planner. The first one is for creating 3D meshes from 2D points, and the other one is a web browser video game that presents the simulation's results in a fun way. FlatMeasure is a tool that turns a set of points on the plane into a three-dimensional triangular mesh of a flat, or building with only one floor. The tool is composed of two parts, a C++ library and a graphical user interface. This application architecture was chosen over a single monolithic application to allow for the creation of many other different tools in the future that rely on the library to make transformations between 2D polygons and 3D meshes. The C++ library is composed of a set of classes for the representation and manipulation of basic geometric entities, blueprints of flats, and triangular 3D meshes. It is able to read from a file the input information, including the coordinates of the 2D points in counterclockwise order, the height of the walls, and the size of the triangles in the mesh. From that, it can create a new file in one of the supported formats with the 3D mesh that corresponds to the given input. The GUI has been created to simplify the definition of the 2D plans and to improve the speed in which these plans can be created and converted into 3D meshes. Here we can see one example loaded in FlatMeasure. We see that we can add or move points, delete them, or split lines, among other things. A test can also be carried out in order to detect problems in the mesh before exporting. When we export the mesh, we can choose between the BEM4i specific format or a more general VTU file. Let's see how the mesh looks in ParaView. Here I'm running a Python script that I wrote that animates the camera inside the building. Wi-Fi Planner is a web browser video game in which the goal is to get the biggest score by guessing in each level the Wi-Fi device that is receiving the greatest Wi-Fi signal from a router and the possible router location that covers best all the devices. There are currently 9 levels, but more can be added easily. In the first screen of each level, we have to choose the device that we think that is receiving the greatest signal strength from the router. Once we press the Continue button, we will see the animation of the Wi-Fi waves coming out of the router. These images have been rendered from the outputs of the BEM4i program after running it on the Solomon supercomputer. After that, we see in the next game screen how well each device receives the signal through a rating ranging from 1 to 5 stars. We can also visualize some slices that represent the propagation pattern at different heights. In the same level, we have now to select one of the possible router locations and try to guess the one that gives the best overall signal strength to all the devices. Then again, we have an animation and a screen where you can see how good was each of the possible decisions and the propagation pattern in different slices for every router this time. In each level, we have to go through the same screens. After the last level, we will be presented with a screen in which we can write our alias to include our score in the top scores screen. The best scores are locally saved so that you can compete with your friends or people around. Thank you for your attention.